Welcome back, everyone. Today we are going to talk about identifying triangles, if it can be a triangle based on its sides, and based on its sides, what type of triangle is it. So first you need to know the triangle inequality theorem. This says that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So if you add up any two sides, it has to be a larger number than the third side. So let me show you an example. It says, is it possible to form a triangle with the given side lengths? If not, explain. So we're going to pair up any two sides. So for example, we're going to take 8 and 15, add them up, and see, is it greater than 17? Is 8 plus 15 greater than 17? Yes, this is true. Now pick another two pair of sides, such as 15 and 17. Is 15 plus 17 greater than 8? Yes, that's also true. And finally, pick the last pair that you haven't paired up, 17 and 8. Is that greater than 15 together? Yes, that's also true. If all three pairs are greater than the third side that you did not use, then you can form a triangle out of those lengths. So this one, you should say, yes, it's possible. Next, part B, we have choose any two pairs to begin. So for example, choose 6 and 8. 6 plus 8, is that greater than 14? No. 6 plus 8 is equal to 14, not greater than 14. So since that's false, you can stop here. You don't have to choose any more pairs. And you can say it is not possible to form a triangle with these side lengths. For example, what might be happening is you have 6 and 8, and maybe this side can't reach over all the way to the 14, for example. It will not form a triangle all the way. Now we can use this to find out the values of the third side that's missing. So it says, if the measures of two sides are 3 feet and 5 feet, what is the least possible whole number measure for the third side? What's the greatest possible whole number measure? So we're going to set up our three pairs just like we did before. We'll call the missing side x. So we have 3 plus 5 has to be greater than x, 5 plus x has to be greater than 3, and x plus 3 has to be greater than 5. Let's simplify each of these. First, we have x is less than 8. Next, we have x is greater than negative 2. Remember, you subtract 5 on both sides just like you would if it was an equation. And finally, you have x is greater than positive 2. Let's go ahead and plot these out on a number line. So for example, if x is less than 8, I plotted that in blue. I circled the 8 and went to the left since x is less than 8. Next, x is greater than negative 2. I plotted in green. I started at negative 2 and went to the right. And finally, x is greater than 2 is in yellow. Now I need to see, where do these three lines all overlap? That is from 2 to 8. So I know x has to be greater than 2 and less than 8. So the greatest number that x could be is 7. Remember, it has to be a whole number. It cannot equal 8 since it has to be less than 8. So the whole number that's less than 8 is 7. And the whole number that is a little bit bigger than 2 is 3. So the greatest number that x could be is 7. The least whole number that x could be is 3. Let's do another one together. I want you to try this one on your own. Example 2 practice. Pause the video and try that one on your own. Here's the correct answer for that practice problem. Solve each of the equations, plot it on a number line, and then you can find your answer. This one did not ask for a whole number value, so it didn't say that it had to be a whole number, so you can just say it has to be greater than 6 and less than 17. For example, your value could be 5.9. Oh, sorry, the other way, 6.1 or 16.99. Any of those numbers will work. It didn't say it had to be a whole number. Next, we're going to talk about classifying triangles based on their sides. So we are talking about the converse of Pythagorean theorem. Converse, remember, we switch the hypothesis with the conclusion. So we get this statement, if a squared plus b squared equals c squared, then the triangle is a right triangle. This also works with different types of triangles as well. If a squared plus b squared is greater than c squared, you'll know it's acute. If a squared plus b squared is less than c squared, you'll know it's obtuse. Let's try this in an example. It says determine whether each set of numbers can be the sides of a triangle. If so, classify the triangle as acute, obtuse, or right, and justify your answer. So we'll start out by making sure this can be a triangle. So we'll pair up all two pairs of sides, 7 and 14, see if it's greater than the third side that we didn't use. All three of these are true. Now, whatever you see as the greatest number is always the C value. So in this case, 16 is our C value. So we'll start out and we'll leave this as an open circle because we don't know if it's greater than, equal to, or less than C squared. So we're going to find that out. So first start with 7 squared is 49. 14 squared is 196. And we want to see how does that compare to 16 squared or 256. So we'll combine the left side together. 49 plus 196 gets us 245. Is that less than, greater than, or equal to 256? 245 is less than 256, so I have a squared plus b squared is less than c squared. Therefore, I'll know that this is an obtuse triangle. Let's try another one. First, always start by making sure these numbers can even make a triangle. So I compare, choose any two sides, make sure that the sum is greater than the third side. And once I find out that that's true, now I can go ahead and see what type of triangle it makes. Remember, the largest side is always c, so I have a squared plus b squared, and I want to see how does that compare to c squared. So I have 81 plus 1,600. How does that compare to 1,681? Add these together. I see that it's equal. Since a squared plus b squared equals c squared, I know that this is a right triangle. Pause the video and try the practice problems below on your own. All right, finally, for your reflection question today, after you check those answers, I want you to read this problem, see if you can determine how far is your house to the shopping center, and explain your reasoning. That's all I have for you today. I'll talk to you again tomorrow. Bye, guys.